Hello everyone, this is Dr. Kishore Kumar, working as Associate Professor, the Department of Robotics and Automation. Today, we'll just look about the introduction to SLAM navigation. The concept of SLAM, that is SLAM is nothing but your simultaneous localization and mapping. So the SLAM concept is very important in your autonomous vehicle and autonomous mobile robots for mapping and localize our mobile robots. So throughout this lecture, we'll just look about the concept of SLAM navigation.
So simultaneous localization mapping. So that is, we need to compute the robot's pose, and based on that we have to map. That is, computing the robot poses and the map of the environment at the same time. So there are three types like localization, mapping, SLAM. So now localization is nothing but estimating the robot's location, whereas mapping, building a map. So SLAM, building a map and localizing the robot simultaneously. Both this localization and mapping should come together. So the SLAM is a technique used to build a map within an unknown environment or sometimes a known environment, while at the same time keeping the track of the current location. So this is the exact concept of your SLAM. So there are plenty of applications of SLAM. It is a central range of indoor, outdoor, air and underwater applications. We can exhibit this SLAM for both man and autonomous vehicles. So examples at home, if you see that the vacuum cleaner, lawn mower plays a major role in the concept of SLAM. Then in terms of air, surveillance with unmanned air vehicles, and underwater reef monitoring, and underground exploration of mine aspect, we can use this SLAM. In terms of space, terrain mapping for localization, we can employ your SLAM concept. And some applications like indoor and undersea, space and underground. In these aspects, we can exhibit your SLAM concept. Benefits of SLAM for cleaning robots. So in this diagram, you can able to see that without SLAM and with SLAM concept is given. So without SLAM, cleaning a room randomly by the clean robot. So with SLAM, cleaning while understanding the room's layout, so that we can get the optimal performance if we employ SLAM concept. So other applications of SLAM, if you see that it is useful in many other applications such as navigating a fleet of mobile robots to arrange shelves in a warehouse, and sometimes parking a self-driving car in empty spot, delivering a package by navigating a drone in an unknown environment. Likewise, we can claim the number of applications of SLAM. So in this diagram, how SLAM works concept is depicted. So if you see that the sensor data, front end and back end data, and along with you will get your pose graph and map estimation. So in the sensor data are given in the front end as a sensor dependent processing. Here motion estimation, obstacle location and estimation is calculated. Then this data is given to the back end, that is sensor independent processing. Here your registered pose graphs and graph optimization concept is enabled. So finally you will get pose graph and map information. So this is where your SLAM works. The multiple parts of SLAM: landmark extraction, data association, state estimation, state update, landmark update, and there are many ways to solve each of the smaller parts. And hardware employed in the SLAM concept is mobile robot, range measurement device, that is your laser scanner, sonar, vision. Depending on our specific application, we can use this type of range measurement device. You see that in the laser scanner cannot be used for underwater, and sonar sometimes not accurate. Vision cannot be used in a room with no light. So based on our application, we can select your range measurement device. And three main paradigms of your SLAM concept is Kalman filter, particle filter, graph based. These are all the three main paradigms. And different types of SLAM algorithms and approaches to SLAM. You see that graph SLAM, EKF SLAM, that is your extended Kalman filter SLAM, fast SLAM, topological SLAM, visual SLAM, 2D Lidar SLAM, 3D Lidar SLAM, and ORB SLAM. So the possible approaches of SLAM, which comes under the different SLAM algorithms. So now extended Kalman filter, it is the heart of the SLAM process. It is the responsible where the robot thinks it is used on the landmarks features. So extended Kalman filter algorithm plays a major role in the almost all the SLAM concepts in autonomous mobile robots. So here it comes the various aspects. So localization example with the concept of same EKF concept, estimate the robot's pose given in landmarks. If you see that here we need to estimate the robot's poses in the given landmarks. Landmarks are given here and the corresponding pose is to be estimated. And estimate the landmarks given in the robot pose with the next subsequent space. So estimate the robot's pose and the landmarks at the same time. So both you are doing at the same time. And the SLAM problem is defined as a chicken or egg problem. That is, a map is needed for localization or a pose estimate is needed for mapping. So we need to concentrate both on map and localization. That is, we need to go for SLAM concept. So a map is also needed, a pose estimate is also needed for mapping. So it is considered a fundamental problem for truly autonomous robots. So in the diagram we have given the concept, that is, your SLAM is the basis for most navigation systems, and we can able to achieve this SLAM concept with this autonomous robots. So why SLAM is hard problem? The mapping between observations and the map is unknown. Picking wrong data association can have catastrophic consequences, that is divergence concept. So robot pose uncertainty is given in the figure. Sometimes picking wrong data associated with the corresponding robots, so we can get some sort of catastrophic consequences. So that time the SLAM may be a hard problem. And known versus unknown correspondence. In the first diagram, the known correspondence is given and unknown correspondence where the robot has to go for the next pose. So we have confusion in the SLAM in the known versus unknown correspondence. And small versus large uncertainty. So here also we have some taxonomy related to the SLAM. And active versus passive SLAM. So here active and sometimes the passive concept, where SLAM exhibit some problem. And sometimes single robot versus multi-robot SLAM, that also some complex may arise in the SLAM versus single robot and multiple robot. So here in this slide there are various MATLAB concepts. The various MATLAB concepts are employed. So even with that MATLAB we can exhibit SLAM for various applications. If you see that MATLAB provides capabilities for implementing SLAM, that is your for various toolbox are available in order to tackle with the various challenges with the SLAM. See here Lidar toolbox, that is your 2-dimensional and 3-dimensional Lidar processing and scan matching with the help of Lidar toolbox and navigation toolbox plays a major role in the MATLAB, especially for SLAM concept. And 3D point cloud processing and point cloud registration is used for your SLAM. And loop closure detection with the help of bag of features, bag of visual words. These are all available in the MATLAB. So object detection and semantic segmentation with the help of deep learning also possible. Map generation with 3D Lidar point cloud using automated driving toolbox also possible. And sensor fusion for localization and multi-object tracking using sensor fusion and tracking toolbox, which is a important toolbox in MATLAB. With that we can go for the SLAM concept. And if you see that SLAM is a very important concept of your autonomous mobile robots and deploying your autonomous vehicles in order to map and localize the robot at the same time. See here the SLAM based systems are inherently mobile, and with the SLAM mobile mapping system it is possible to simply walk through an environment with a digital map. And saving time and money, removing laborious setups from equations is possible. SLAM based mobile mapping systems slash survey times and can be over 10 times faster at acquiring data, and the SLAM based technology overcomes the obstacles by cutting out GPS altogether. Thank you.